Welcome back, everyone. I hope you enjoyed the previous sessions and you had short relaxation time during our break. For everyone that was not able to see the intro from the previous sessions, my name is Daniel Pando, and I'll be hosting the first few sessions of Almadina Room. I'd like to start by thanking everyone attending, thanking our speakers, and obviously our sponsors for making Generation possible. And I'd like to leave out a special thanks to Devlin Duldulao from Microsoft. Is a Microsoft MVP and is going to present us a session on automating your infrastructure deployments into Google Cloud, Azure, AWS, with Terraform. So if you have any questions you would like to drop to Devlin during the session, just leave them on Generation Slack on Almadina channel or YouTube chat, whatever you prefer. And I'll try to relay them to Devlin at Q&A. So Devlin's presentation will be pre-recorded video, but it will be here for the Q&A. So you will be able to answer your questions. So without further ado, let's move to Devlin's session, and we'll check back on Q&A.
Hello, everyone. I'm Devlin Duldulao. I'm a software developer in Meta, and I'm here to talk about automating your infrastructure deployments in the Google Cloud, Azure, and AWS with Terraform. But first of all, I'd like to thank JNation for giving me this opportunity here to speak at this conference. Yes, so let's start. So, infrastructure as code, which is sometimes called IAC, uses automation to manage infrastructure. For example, instead of configuring your servers one at a time, you use a tool to configure all of them at once. You express the infrastructure you need for your application as code, such as a configuration file or a script. What infrastructure as code can do? Can eliminate manual error-prone provisioning and changes, bring software best practices to infrastructure management, gain visibility of changes through code reviews and previews. And now, why infrastructure as code? We have this automated and repeatable, decrease time to market for new applications and ongoing maintenance, safe, predictable changes. In short, you have increased speed, reduce risk, reduce cost, and leverage developer best practices. And we have Terraform by HashiCorp here. So Terraform uses infrastructure as code to provision and manage any cloud infrastructure service. You can write declarative configuration files. Define infrastructure as code to manage the full lifecycle, create new resources, manage existing ones, and destroy those no longer needed, plan and predict changes. Now, Terraform provides an elegant user experience for operators to safely and predictably make changes to infrastructure, then create reproducible infrastructure. Terraform makes it easy to reuse configurations for similar infrastructure, helping you avoid mistakes and save time. Terraform in itself is an open source tool by HashiCorp written in the Go language. The Go code is compiled into a single binary. This binary is used to deploy infrastructures or build a server using just a shell. The Terraform binary makes API calls to Google Cloud, AWS, Azure, OpenStack, etc., thanks to the Terraform providers maintained by the community. And yeah, Terraform Cloud, we have their own software automation, and you can get it from Terraform Cloud. This automation and collaboration features to empower individuals and small teams including VCS integration, remote operations, and state management. You can also create multiple teams and ensure that team members have the right level of access to the appropriate configurations, and leverage the Sentinel policy as code framework for enforcing fine-grained policy against everything that Terraform Cloud provisions. You can also view cost estimation, so you can preview how much configurations will cost before they are deployed. Here's a sample file of Terraform. I name it foo.tf. It's like say YAML, but different. Braces are only written once per block, and then this is variables like a parameter value you can pass, and then resource, for example this one, Google Compute Network, and you have fields here, boolean, string, or integer. And after defining this, actually you can also write conditional expressions here. For example, if var a is an empty string, then the result is default a, but otherwise it is the actual value of var a. Another one in here, function calls. For example, the min function takes any amount of number arguments and returns the one that is numerically smallest. And another example here, for expressions. If var list is a list of objects that all have an attribute ID, then a list of the IDs could be produced with this expression. And here are common commands, Terraform commands. You have Terraform init that will download the plugins that you need for provider. And then Terraform validate, it's grayed out because you can run it or not. It will just validate your code inside the file. This Terraform plan is more important here. Well, it's like a dry run. It shows you what's gonna happen in your own cloud service account. Like, will it create new resources, or update it, or delete them, or delete some. And we have here also, by the way, that's a best practice. Always run Terraform plan for applying, and then Terraform apply. There's also a Terraform apply flag that you can use, auto approve, because if you don't put auto approve, it will ask you, or prompt you if you're sure of these changes, like that. And there's also Terraform destroy, which destroys all the resources you created. And by the way, it can also delete resources through just by deleting the code of a resource in your file, and then Terraform plan again, and then it will tell you if these resources will be deleted from, say, an existing resources. Okay. Demo time. Let's show some demo here. So, okay, let's try this local or Azure. So here's a sample of Azure code. We have service plan here, resource. No, I think this is there's a better way to show you. This is just a basic one. and I'll just delete this. This is from a previous testing that I did here. Normally it's just like that. It's the original status of that. And then let's run this Terraform init. No, let's go to that directory first. Local, then Terraform init. Checking for available provider plugins. That's fast. Here's the binary. Then Terraform plan. Let's see. Let's move this here. So see. Okay, while waiting for that. Oh, yeah. Here we are. So as you can see here, there are green cross here icons, meaning they'll be added, and the plan is 5 resources will be added. There'll be no changes, and there'll be nothing to destroy here. Nothing gets destroyed, and yeah, after this you can now run Terraform apply. Then of course gonna ask me yes, Terraform will perform the actions described above. Only yes will be accepted to approve. Yes. Now while waiting for that, let's check this out first. What's inside of this main.tf Terraform file. So we have the required version here, Terraform. This 0.12 version or above, and the provider, which provider? Here is Azure, and these are required here, by the way. Features, resource group. So this is what we're building here, and there's an alias dev. You can write anything you want here, and it requires name field, location. Here's service plan, and there's another dev alias, and the service plan needs name, location, resource group name. So this is how you'd write it, just to get the value of this. So resource, you can see resource group. This is dot dev, and then dot name. Basically you're also reading this here. Then SQ, standard, S1. What about the app service? Dev, we have name here, location, resource group name, app service plan ID, site config, .NET framework version, app settings, some secret, connection string, for SQL Server. These are the fields. So this is not advisable. You should put this in environment variable. There are 3 ways to do that. You'll find out later. So SQL database here with some fields and tags, environment production, right? And then the Terraform state file. It's here. It's being used by Terraform apply that we just run. Just leave it there for now. So Yeah, it's not that hard. So let's go to another example here. Well, there are outputs here. You can see outputs file. It actually just helps you see, for example, you want to get a value for the name, say the main name, what's the URL. So just a helper in your command line. For example, here, if you want to know the SQL server name, it will be shown here, and then the value of it. So that's what outputs are for. Providers here, subscription, client ID, client secret, the variables. Well, actually, you can write your variables here in outputs, and you can also put it in a separate files, like so. And then you also have versions here. You can separate it. You can see here we didn't do that. So this is just one single file with all the things that you can do. Whereas this one is we separate the outputs, variables, providers, and version. Put in their own file. Okay, I think we're done here. Apply complete, resources 5 added, 0 changed, 0 destroyed, and we can take a look in the Terraform TF state file. Here it is. So you have to keep it this one and put it in a safe place. So this is the history of your resources. You don't want to edit that. Just don't touch it. Now let's go to my Azure account and see if the resources do exist there. Let's refresh. There you go. Local Terraform demo RG. I think I can move this up here. And here's the app service plan, the app service, SQL Server, and the SQL database. So it's very simple. Now next is, let's try Google Cloud. See the Google Cloud, GCP. Also, okay. I'll try to delete this also. So, Terraform init. Let's clear this up first. Terraform init. See, no Terraform here. Downloading plugin. Again, for provider Google. Now here it is. Binary. Then next is for validate. Let's see. The code is configuration is valid. How does it look like? So here it is. So we're stated provider is Google, and for the credential, it's saved in this file, service account.json, where it's being referred here. Then needs a project field, region, zone, using variable here. Let me show it to you, variables. So So these are the values. This default, and you have this optional description. So this is just compute instance and firewall, instance group, health checks here, compute backend service, security policy, global forwarding rule, target HTTP proxy, URL map. Yeah, and here's an output. You don't, no need for putting in a separate file. It's just one line here. So yeah, there's an IP. You can see that later. Let's try to run that Terraform. Did I? Terraform, not yet. Plan. Go. So here it is, and it says "11 to add, 0 to change, 0 to destroy." Okay. So before we add this, let's delete the other one first. The Azure resources is created. CD local, and then Terraform. Destroy. Terraform. Yeah, destroy, auto proof. Yeah, that's it. And the other one, just Terraform, apply, then auto approve. It's just, yeah, I know what I'm doing. Auto approve. Okay, this will take probably 5 minutes, so we have to move to our next slide, I guess, or maybe we can check out this one for the AWS. Yeah, so for the AWS, here it is. We have provider here. Again, we're stating AWS with the provider, and region US is to. Now this is sample of commenting here. I have to use this pound sign or sharp sign, and here we're going to create configuration, launch configuration. This is just T3 micro AMI image, this unique serial number. And then with the security group, there we go. I think we're done here. Let's check this out. So yeah, this is the, remember the output that I told you what it does. It shows you something here. For example, this one. This is GCP, so you want to know the IP, the Google Compute Global Forwarding Rule, default IP address, so here it is. It's just for the developers. Okay, we're able also to delete the resource, Azure resource. Let's check that out. Okay, you refresh this, it's begun. right? And what about the Google Cloud? Okay. Refresh. How to refresh this first? Just refresh. Here it is. And yep, this is the resource we created from GCE. That's right. Yep. You can delete it here. You can also delete it through Terraform. Okay. So next would be AWS. Here. Let's try that. I think that with here. Then CD, AWS, Terraform, init, then Terraform plan. I don't think we still have enough time for this. AWS, as you can see, here it is. Plan, 5 to add, 0 to change, 0 to destroy. And I can move to next slide. So basically that's it. Now you can deploy to Azure. You can create resources. You can also create resources in Google Cloud and AWS. So Terraform state, again, it's JSON format. Do not touch it. Do not try to edit it. So resources, mappings, and metadata, and you can save it locally on your machine, or save it remotely in AWS, Azure, and or Terraform Cloud, and also in Terraform workspaces. So this is Terraform included in a CI/CD pipeline, and here's a build process. After checking out your code, pushing your code, creates an ASP package here, zip, and the release definition, creates a storage account in AWS, a separate resource group. Save the key, and then it's provision the for example here app service, and then storing the Terraform state here. Eventually here comes the ASP.NET package zip deployment, and now you have this application. So you can include, again, you can include the Terraform file in a monorepo, or you can put it in a separate Git repository. Depends. It's just self-preference. Well, maybe if the project is just a small project, you can put it in a same repository. But if it's a large project, I think it's better to put the Terraform file in a separate repository. So you can save it in a storage account inside a container. So this is actually in Azure, and for AWS, S3 bucket, and for the Google Cloud, it would be Google Storage or the GCS. And demo time. I think I have to show you that CI/CD pipeline and the release pipeline. in Azure. So here it is. So why? Okay, let me step back here. I forgot to ask you, why do you have to put it in a separate resource group, the storage, so not be able to accidentally delete the Terraform state. For example, if you run Terraform destroy accidentally, of course you will not be able to recover it. It's lost. So it's a good practice to put in a separate entity. And here's the release pipeline. First task to use this Azure CLI to deploy our required Azure resources, and that would be the for the storage. As you can see here, it's a resource group, a location, and then with the container account name here. Then after that, running a PowerShell script here. So basically this thing here gets the Azure storage account key, so that you can save the Terraform state file in this Azure storage here. And here's the Terraform here, installation, then running the Terraform init, Terraform plan, then Terraform approve, and as you can see here this is auto set to auto approve. Here's a flag here we're using, so to not interrupt the process here. Then finally the service deploy. So let's differentiate Terraform from the other tools out there, like other provisionary tool or configuration management. So anyway, here's Chef. First of all, Chef is a configuration management tool versus the provisioning tool that Terraform is. Chef is concerned with the installation and management of software on existing servers, while Terraform provisions the servers themselves. In this case, when using Docker or Packer, Terraform is a better choice than a configuration management tool, but it's more Chef defaults to mutable infrastructure paradigm, leading to hard to diagnose configuration bugs, but Terraform treats every change as a deployment of a new service configuration. Chef also represents a procedural style to code everything and requires running a master server for state storing, as well as agent software on each configured server. So what about Puppet? Similarly to Chef, Puppet is also a configuration management tool used to install and manage software on already existing servers. It also requires a master server for storing the infrastructure state, as well as the installation of an agent software for installing the latest configuration management updates. Puppet is also 4 years old than Chef. It was released in 2005. However, Puppet has a more declarative style, just like Terraform. And here's a SaltStack. Although SaltStack is again a configuration management tool, it has a more declarative style like Terraform. And then like Ansible, Chef, and Puppet, it is mutable infrastructure paradigm. It requires the installation of agent software and to run as a master server. Lately, SaltStack has been gaining an increase in developers' interest. There's even an annual SaltStack user conference. So here's Ansible. Like chef represents a procedural style of coding. Yeah, so it is a configuration management tool and follows a mutable infrastructure paradigm. Here's Ansible here, you can see, and this is how would you use it along with Terraform. So you use Terraform to deploy all the underlying infrastructure, including the network topology. That would mean VPCs, subnets, route tables, then data stores like MySQL, Redis, and you have load balancers and servers. You then use Ansible to deploy your apps on top of those servers. Here's a quick diagram of that. We have Terraform here, and then Ansible. So let's go to Packer. Packer automates the creation of any type of machine image. It embraces modern configuration management by encouraging you to use automated scripts to install and configure the software within your Packer-made images. Packer is an automated build system to manage the creation of images for containers and virtual machines. Packer, on the other hand, is a system for building, distributing, and running Docker containers. Containers can be run on Linux and Windows. So basically, that's to differentiate Packer from Docker. So here's Terraform and Packer. You use Packer to package your apps as virtual machine images. You then use Terraform to deploy servers with these virtual machine images. And then the rest of your infrastructure, including the network topology, then data stores, and then load balancers. Give you an example of that. Here's a Packer, Ansible, and then Terraform. Packer sends this Packer image built to create a VM. And then the Ansible install middleware and application. And then the Terraform provision load balancer, VM scale sets using management this image. That's an example of that. So here, both Kubernetes and Terraform can help you with orchestration and scalability. Kubernetes deals with Docker containers. So if your application isn't yet containerized, it will require some preliminary work. Terraform operates on what can be seen as hardware. So it's suited for any kind of workload. So here's a table of Kubernetes and HashiCorp stack. Here's Kubernetes and packaging. It uses Docker, deployment and provisioning. It's Helm here. Here's Terraform, and then Packer. Then here's Terraform, Packer, and Docker. Terraform, Packer, Docker, and Kubernetes. You use Packer to create a virtual machine image that has Docker and Kubernetes installed. You then use Terraform to deploy a cluster of servers, each of which runs this virtual machine image, and the rest of your infrastructure, including the network topology, data stores, and load balancers. Finally, when the cluster of servers boots up, it forms a Kubernetes cluster that you use to run and manage your Dockerized applications. And here's Pulumi. Pretty much the same as Terraform. The only difference is that Pulumi uses JavaScript, TypeScript, Go, Python, and C#. They both do the same thing. Okay, so yeah, this is just a sample of package managers, JavaScript, TypeScript, Lumi, and Azure. Yeah, this is a provider of links. Yeah. So let's move to CloudFormation. So it is also a provisioning tool. However, CloudFormation is non-open source. It's like Terraform. Terraform is open source. This is non-open source. The tool belongs to AWS services, which means it can only be used within AWS scope. And we have here Azure Resource Manager of Azure, same as Terraform, but can only be used in Azure resources. Yeah. And then Cloud Deployment Manager, Google Cloud. Yeah. Non-open source as well. It uses Jinja of Python. Jinja is a modern and designer-friendly templating language for Python, modeled after Django's templates. So we're almost done here. Summary: IAC, consistent, gives you these things here. Consistent configurations, improved scalability, faster deployments, less documentation because the scripts replace it already, right? That is so good. Better traceability. And the Terraform here, you have one tool and one language for describing infrastructure for Google Cloud, AWS, OpenStack, and any other cloud. Switching a provider is not a headache anymore. You can have Amazon instances running Kubernetes containers with your workloads and manage the whole system from one tool. You can go here to learn more about Terraform, terraform.io. And here's a link to Terraform Associate certification. If you want to add formal industry accepted credentials, digital badge upon passing a certification exam. And yeah, here's a Terraform book. You learn here a lot of stuff, like how to create reusable infrastructure with Terraform modules, some Terraform tips and tricks, like in let's say loops, if statements, and pitfalls in Terraform, and how to use Terraform as a team, which is really important also. So yeah, thank you for listening. Please follow me here, my Twitter. Yeah, that's all. And I'm out.
So thanks a lot, Devlin, for the great talk. We do not have many questions, although some of the guys are asking if you can share your GitHub link on the channel and your slides. Although just to let everyone know that these sessions will be available to be viewed after the conference. So if you are interested in the whole session and not just the slides, which I think will be better because you actually have the code, the live coding and the live demo, they will be available after the conference. So I don't know if you want to add anything else, Devlin.
Yeah, just if you have questions, just post it here on this YouTube chat or on Slack, and I'll be happy to answer all of them. And of course, the link to the slides and the repo.
Yeah, Devlin is also on our Slack channel. So if you want to reach him with any questions, just let him know. I think he will probably be able to answer your questions throughout the day.
Yeah, of course.
So once again, thanks a lot, Devlin. Hope to see you back in a future year to Generation. And thank you for the great talk.
Oh, thank you. Thank you also. Yep. Thank you, everyone, for listening, for watching. Thank you for J Nation for this successful event again. So yeah.
So we'll have a quick break now, and we'll be back in 13 minutes to a session on how to build an app for the Google Assistant. Tune in after for that. See you in a while.
Stay safe, everyone.
Thanks, Devlin.